So we're talking about the difference between mass and weight. Weight depends on mass. That makes sense. A more massive object will have a greater weight. Okay. And we know that we can calculate that because weight equals mass times gravity. So weight equals mass times gravity. And we know that every number has to have a unit. So in the United States, we use the same unit for weight and mass, so it's highly confusing. We use the pound. And that's one reason that a lot of times, like, students don't realize that weight and mass are truly a different thing. But everywhere else in the world, the weight is measured in a newton. Give me a thumbs up if you already knew what a newton was in that context. Not many thumbs. Okay, so let's write a little bit about newtons. Newtons are kilograms times meters per second. So what that means is 1 kilogram, 1 newton can take a 1 kilogram object and move it 1 meter per second. So that's an acceleration there. So newtons is a force. Weight is a force. Okay. That's kind of a weird thing to think about, but measured in newtons. So when we look at the unit, this derived unit of newtons, kilogram meters per second, we know that mass, we already talked about mass quite a bit, mass is measured in kilograms. The base unit of mass is the only one that has a prefix on its base unit. Alright, so that makes sense of where the kilograms comes from. That means that gravity then has to make up the rest of this unit. So gravity, we're going to say a few things about gravity. But the number, the acceleration due to gravity, is 9.8 meters per second. We can throw that number out and we can memorize it, but what does that number really mean? We see meters per second. So meters is a distance, seconds are time. So this is an acceleration. Gravity is accelerating you 9.8 meters every second, and greater for every another second. Now that is a mouthful, but gravity is accelerating you. What is it accelerating you towards? The center of mass, the center of the earth. Okay. Now, what gravity am I talking about here? What gravity do you think about when you think of the word gravity? Earth's gravity. So we should probably elaborate on that just a little bit. Right? Because every object of matter has its own gravity. So it's kind of a crazy thing to think about. You have a gravity. You have an attractive force that compels people to be close to you. That sounds good, right? The second part, not so good. It's just that your attractive force is not nearly as great as the Earth's attractive force. Why is that? Because the size, you're so small compared to the mass of the Earth. So the Earth's mass is so humongous that it can hold you to it. But don't forget, you have an attractive force. It's science. It's real. Okay. Anyway, that was silly. But, alright. So gravity is an attractive force. Let's go ahead and write that down. It is an attractive force between matter. All matter has this attractive force. It's just that you have a huge, great mass like the Earth, then your attractive force is pretty strong. If you have a small, tiny mass, such as a human, you can't exactly pull things towards you. Okay? Alright, so what else? If we look in the lesson, you can see a data table that tells you the body, the celestial body, so like the sun, other planets, and then multiple of Earth's gravity. So we're going to take a imaginary human, okay, who an average size human is about 150 pounds. So if that human, we're going to stick with pounds just because we can associate that with our own weight, even though it's not the SI unit. The average human is 150 pounds. Then, according to our data table, on the sun, his or her weight would be 27.90 times that. So this person's weight would be 4,185 pounds on the sun. That's a little crazy. Like an average sized human, 150 pounds on Earth, would be 4,185 pounds on the sun. That's like a crushing force of you. I don't know that your muscles or bones could move with that kind of weight on them. Okay, but what about on the moon? We'll take our same average sized person. Okay. On the moon, according to our data table, the moon would be a multiplier of 0.165. So this 150 pound person on the moon would have a weight of 24.75 pounds. So that's why, like, you see those people on the videos from the moon, they're kind of bouncing around. 24.75 pounds doesn't take a lot of muscle to push when you're used to pushing off 150 pounds. So weight is an effect of gravity of the planet that you're on. Okay? So if we look at the planets, so not the sun or the moon, if we look at the other planets, Jupiter, you would have the greatest weight. On which planet would you have the smallest weight? Mars has 0.38. Mercury has 0.377, so Mercury. But would your mass be different? No, you would have the same arms and legs and bones inside. You'd have the same mass, the same stuff, but your weight would be different. So it's just kind of a picky, sciencey thing, and like I said, a little bit more physics than chemistry on that one. But I'm going to go ahead and give you the other words that we need for today, and then we'll watch a couple of the videos and do a couple of the other parts in the lesson. Kinetic and potential energy. Kinetic energy is what? You guys know this. The energy of motion. Okay, so that's movement. There's something happening with the kinetic energy. Whereas potential energy is possible. You guys have learned that from somewhere, because 6th period said energy of possibility too. So we'll write that. Okay. I like to say or waiting. Waiting energy. Energy that's there, but it hasn't done anything yet. And there's several different kinds of potential energy. Okay, there's chemical potential energy. So within the bonds of chemicals, within chemical bonds, different bonds have different energies in them, and that's where the energy is released in foods and in cells. gravitational potential energy. So how far you are from the surface, what distance there is for that acceleration to occur. Kind of like if you put a book on top of the bookcase and then knock it off, it's going to make a louder sound. It's going to hit harder on the floor than if you knock it off the seat in your chair, right? So the higher an object, the more potential. I can't write. There's elastic potential energy. Elastic potential energy. What is elastic? Some of you have stretchy, right? So if it's stretchy, if I stretch it out, it's going to have more elastic potential energy. It's kind of like if someone throws a rubber band at you, is it going to hurt? No. But if somebody stretches it out and zings it at you, is it going to hurt? Yeah. So that hurts more, is that increase in potential energy. So I said that in 6th period and they looked like they were offended at me. And electromagnetic. We will talk about electromagnetic when we talk about atoms and their behavior towards one another when they have a polarity. But just like it sounds, it's an electricity, magnetic, so there's something to do with the polarity there. So we're going to say plus goes to minus and minus goes to plus. That's the easiest way to think about it. There's that opposites attraction. We're just talking about attraction all day today, aren't we? But, alright. 2 more words and then we can have a little bit more fun. Maybe. Observations and inferences. These 2 words usually go together. Why is that? Right, you have to make observations first. So observations are using the 5 senses, including measuring, because you got to use your eyes to measure something. To gather facts or data. But an inference is what? Inferences are what your brain does with observations. So conclusions. So conclusions that you draw. Sometimes that's immediate, and sometimes it takes a while to put it together. But somebody in the earlier class talked about context clues. So observations are your context, inferences are what you do with them.